Hi, and welcome to day 24, like maybe day 10 or whatever, of me streaming Advent of Code. Wait, day 10 of me streaming and day 24 of the Advent of Code problems. Yeah, so I will be trying to solve them in Go again today. I did already have a look. So I come prepared, and we will just see how we get on with it. So yeah, let's just start. The problem today, I've just looked through it, is we are supposed to implement a hex grid, like a hexagonal floor pattern. They linked to this. I don't think it is actually this one. Is it this one? Let's see. There's east, southeast, southwest, west. Yeah, it's not this one. It's this one, like rotated by 90 degrees because there's an east and a west. But yeah, we have like this tiling of the floor, and all the tiles start off as as white. And then we have a list of instructions, of like a list of directions that we should walk. So like southeast, southeast, northwest, northeast, and so on. And then like the one we reach at the very end is the one we are supposed to flip. And at the other side it's black. And so we just walk through all of these lists, and like for each list walk through all of these directions, and then we are supposed to like flip the tile, and at the end we are supposed to just count how many overall are black. So it's a reasonably simple problem, and when I saw this problem, what I was thinking of is a couple months ago a blog post flew through my Twitter stream, and it's this one, implementation of hex grids. And I was like, when I saw that, I was like, oh, I remember that I read about how to do all of this, because obviously like the difficulty here is how to implement a hex grid in a like computer, in a one-dimensional memory layout, and all of that. And so this walks through like a lot of different options for how to represent hexes, how to like transform between different ways of transforming them, of representing them, how to calculate distances, all of that stuff. It's meant for like game implementers, but we can also use that. And so I looked it up again, and I actually linked it in the description so that you can also have a look. And what I will use is what they call cube coordinates. So you have 3 coordinates, QRS is how they called it, and then you basically, so you use as a restriction that their sum must be 0. And the reason for that is that, like, if you just have 3 coordinates, you have a 3-dimensional space, so you need to remove one degree of freedom to get to back to two dimensions. But you still want to have like 3 different coordinates so that you can easily move along the different axes that the hexagon has. And they also provide, at the very bottom, they provide a list of examples, I think, offset coordinates, fractional layout examples. And so the one I will be using is this one, because it uses the same kind of orientation of the hex grid. And I have this open here. And so like we have 3 coordinates, and as I said, like we want the sum to always be 0. And so basically what we like, the way this works is when we move in a direction, we will increase one of the coordinates by 1 and decrease another one by 1. And so as a result, we don't change the sum of them all. And then depending on which direction, we will choose different ones to increase and decrease. And so this actually gives us exactly the coordinates we want. So like we would start at 0, 0, 0, and then if we go east, we would decrease the first one and increase the last one. If we go northeast, we would like decrease the middle one and increase the last one, and so on. And so you can see that like each direction represents a different set of things to increase and decrease, and like we always, like the opposite ones always use the same coordinates. Yeah, another way to think about it is that you always like leave one of the coordinates unchanged, and basically the axis determines which coordinate stays unchanged, and there are like 3 of them. And yeah, anyway, so this is what we will do, is we will use this representation for our hex grid, and we will use a hash map to store the color of the tiles in, and then we will just walk through the stuff, and hopefully this will be relatively straightforward. So let's start with this. Again, package main, func main. I will first define a type hex, which has like these 3 coordinates. I could also just use a 3 vector. Yeah, I think, I don't know. I think I will just use an array with 3 integers. And then we have directions, which we will just represent as an int for now. And we will use like Go's version of an enum for that, which is to say there's like, we have, where do we start? Let's say we just start with east randomly. So this is the right direction. Is a direction, and it just starts with Jota. Jota is in case you're not familiar, is a identifier that you can use in a constant declaration in Go, which will just increase with every line. So it starts at 0 and then goes to 1 and then goes to 2 and so on. So then we can do southeast, southwest, west, northwest, northeast, and would go back to east. Right? So now these are our directions. And then we can, on our hex, do things like we can walk into a direction and return a new hex. Now we have to, I will move this over to this workspace for a second. We can look at our representation to see what we need to increase and decrease. So switch direction, case E. So E will decrease the first one and increase the last one. So we return a hex where the first one will be h0 minus 1, the second one will be unchanged, the third one will be increased. And then we will do this for all the directions. 2, 3, 4, 5, 6. Now southeast, southwest, west, northwest, northeast. So west obviously does the opposite from east. Southeast is southeast is it will increase the middle one and decrease the last one. Southwest decreases the first one, increases the middle one. So it's this. West does the opposite of east, we already have that. Northwest decreases the middle one, increases the last one. And northeast will increase the first one, decrease the middle one, and leave the last one alone. And we will just say if it's not one of them, we will panic with an error unknown direction %d. And this implements our walking, right? Yeah, and then we can also just do a type grid, which is a map from hex to color. This will be our floor layout. and the color can just be either black or white, and we will do that the same as with the directions. We will basically do an enum. And I use, because all of them start out as white, I will use white as the first one, because if a key in a Go map is not defined yet, and we access it, it will just give the 0 value. So the 0 value will be white, meaning like our grid starts off initialized as everything is just white before we even put anything in. And black will be the other color. And so this is everything we need in terms of types, I think. And now we just need to implement the reading the instructions. Oops, we will, as we always do, we will have a function read input, which takes a reader, which will usually be stdin in our case. And what it will do is it will return a slice of slices of directions, right? Like every line is a series of directions. And so we want to return a slice of direction and an error. Right, and as we always do, we will also start buffer with a buffer.io scanner to go line-wise through the input. This should be s for s.scan, and then return, and we will have like var out, which will be the output, return out s.r. So this is the basic scaffolding for our input parsing. And then every line will be a series of directions, and one thing we like, some of the directions are just one letter, and some of them are two letters, and so we need to be like a bit careful that we delineate them correctly. But it is unique, like it is. Even though, for example, SE also contains an E, like we can always say when we look at the start of a direction, we can delineate whether it has one or two letters, because if it starts with it, like it either starts with an E or it starts with something that isn't an E, and then it might have two letters. I don't know. It will. I hope it will become clear soon. So the current tile direction, the current tile of the tile we describe by the current line will be T, and then we will just say for length. So L will be s.text. For len L, as long as there are still as long as there's still text left, we will say switch L0, and I will handle east and west first. So east, west. So actually we can just say there's like north and south. And if it's none of these, we can just directly abort, because that's obviously like an invalid input. Invalid character %q in input. Now, if it's east or west, we can just say tile equals append tile east and continue. And if it's west, the same. Now, if it's north or south, then we have to read the next letter. So we will skip these, like we will not have anything in here for now, because we need to do more work. And now we can, but now we have to catch the case that in theory, like the string could be empty, like this could be the last letter, which is an error, but we need to handle that error. So we say if len L is 1 in this case, like we already know it's greater than 0, but if it's just one letter, then we can say fm.error truncated direction %q. Oh, this q should actually be 0. And we return an error. And if not, then we can say, I don't know, how do we do this best? I don't know, if L0 is north and L1 is east, T is append, T, not tile, but T. Northeast, else if we should use a case, just a switch, and then do case, oops, case this T equals append T northeast, and duplicate this like 3 more times. Then we have northwest, then we have southeast, then we have southwest, south, southwest, right? And now, oh, this is something I didn't do. I actually need to do L equals L1. We need to trim off the first character because we've already handled that. And in this case, we will trim off the first 2 characters. Yup. Yeah, and so now we have like passed the entire line, and we will just add it to our output, the tile that we are getting directions to. Yeah, so this, I think this looks fine. I will, just to make sure, again, I will debug print it, and for that I will add a string function to direction. There are tools to do this automatically. There's something called Stringer, which is a Go tool that just takes, uses like a constant like this and writes a string function for it. I prefer to just do it manually. It's a bit boilerplatey, but I only need to do it like every once in a while, so it's fine. Seven. Southwest, west, northwest, northeast. Oh, it's just 6 directions. And default, panic, dot error, invalid direction %d. Yep. Great. So and then we can just directions is, or like let's call it tiles, is read input os.stdin, and if r is not nil, log.fatal r, and we will also set the flags to log a short line again, so that when we do debug outputs, we get the line short file. We get the line numbers so that we can like easily see where errors are coming from. And then we will just, for now, just print all tiles and see what happens. Like all tile. I should leave this as one for a second. So let's build this. Syntax error. This should be func, of course. Invalid case E in switch, direction and bool 56, switch D. Cannot convert error to buffer.io scanner. Yep, because this should be buffer.io new scanner. Cool, and I already have the input and also the test case from the left side. So I can actually do this here now. So we can just put the test case in and see whether it does what we would expect. So the first one is southeast, southeast, northwest, northeast, northeast. No, Batman. Sorry. W, southeast, east. So this is for example where we can see this in action, right? Like this is southeast, southeast and east, and not like southeast east, because south alone doesn't exist, but southeast exists. So we like swallow these two and then have an E. So this, I don't know, this looks good to me, so let's press on. And like, feel free to leave a note in the chat or whatever if I'm going too fast or too slow or generally not understandable. So what are we now supposed to do? Now we are supposed to take these directions, like each of these gives us a path to walk in the grid, and we are supposed to walk the path like for each of these lines and then color, like flip around this tile. So if it's black, make it white. If it's white, make it black. And so we might hit the same tile multiple times because the directions are not unique, right? Like we can, if we want to reach like this tile, we can go like northeast, northwest, northwest, or we can go like west, west, northeast, northeast, or something like that. So the directions are not unique, and so we might hit the same tile multiple times. Then we will just flip it multiple times. So func flip tiles. So we will just say flip tile, which will just take one slice of direction, and a grid. We actually will just make it a method on grid because why not? And this will just do it in place. That's fine, I think. And so we start with the 0 hex. The instructions are like you always start from the list of tiles that need to be flipped over. Each line list in the list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile. So the reference tile will just be the 0 tile for us. So in this grid, it would be like this tile here, the middle tile. So this is our tile, and then we will just say for every direction in T, or let's say, I don't know, in DS, let's say, and I already implemented this walk this tile, right? So let's just say this will be h.walk in direction D, and now H should be the tile that we want to flip, so we can just say GH, so this is the color. We can say if GH is black, GH will be white, else we say GH will be black, right? Simple enough. So this should actually, this should just do what we want. We can also, in the interest of super clean code, we can say flip a hex, which will do exactly this for like super clean code, and then just say g.flip this hex. And now we just go through all the tiles. So we say G will be make a grid, and G will be g.flip tile T. Right, and now G should be the grid with all the tiles flipped that we want flipped. And so the last step is we are supposed to count all the black tiles. Like obviously there are infinitely many white tiles because we are supposed to assume that the grid is like large enough for however large we need it. So it's like infinitely large. But there are only finitely many black tiles because it's like only by flipping them we will get them. And so let's say func g grid count black tiles, and this will just return an int, and we will just go through the grid. We are not interested in what coordinate is what color. We are just interested in what is the color of the different tiles, and we say if C is black n++, and we return n, and this should give us the correct output that we want. So let's fim.println, oops, number of black tiles, g.count black tiles, right? Let's build this and see what happens. Cannot use range. I always forget range. Ironically, like this is somewhat ironic. Ironically, this error that I forgot to say range does not happen to me if I don't use syntax highlighting, or maybe if I don't code live. But I don't know. I'm not saying that syntax highlighting is bad. I'm just saying this is one of those ironic things that even though like naively range is even highlighted with syntax highlighting, it seems that this just doesn't help me. Why does govim highlight 4 again? I don't know. I honestly like I will send a timestamp video of this and ask Paul or someone why what this highlight means and how can I get rid of it. So this says 18 black tiles of the test case, which is I think wrong. We are supposed to have 10 tiles. Damn, we did something wrong. Let's see where we went wrong. And about 10 tiles are flipped once and 5 more are flipped twice. After all of these instructions have been followed, a total of 10 tiles are black. 10 tiles are flipped once and 5 more are flipped twice. Okay. Okay, so what is happening here? We might have the directions wrong, or we might have wait, the flip tile, this looks fine, right? If the walk fits, if the walk is the right one, this should be done. The flip looks also right, correct. If it's black, make it white, otherwise make it black. This looks also fine. The parsing, we already checked that looks somewhat like that, looks mostly right. Append northeast, append northwest, southeast, southwest, truncate out equals append out. So the only thing I can think of that is wrong is the walk code. So let's first check that the opposite things are actually the opposite. I will move them closer together. So these two are opposites from each other. This looks correct. Southeast and northwest are, and northwest are opposites. They also look like opposites. Southwest and northeast are opposites, and they also look like opposites. And count black tiles. If C is black, increment it. The code seems correct to me. And we have 20 lines, and which is the right number of lines, but we are only flipping 2 of them. Let's do debug printing as always. So log.print, or let's do it. Okay, log.print walking from %v, walking %v from v, and v will be the direction and h will be the hex. And then in flip, log.print flipping tile %v from black to white, from white to black. And then at the end we will do a new line to delineate. Go build. Okay, missing. Great. Hex. Okay, let's look if this does what we would expect it to. So in the grid, so the first we start at 0, 0, 0. We then walk southeast to southeast 0, 1, minus 1. Then walk northwest to no, we then walk southeast again to 0, 2, minus 2. Then we walk northwest, which will bring us back to there, which and then we go northeast, which brings us there. Then we will move northeast again, which gets us there. This is also the right tile. Then we will walk northeast again, which brings us there, 3, minus 2, minus 1. Then we walk west, which should get us, wait, west is there, right? Oh, did I swap east and west? So this is, we are here, 3, minus 2, minus 1, and then we should walk west, so the next tile should be 2, minus 2, 0, and instead we end up at 4, minus 2, minus 2. So walking west looks wrong. Let's look at walking west. Walking west, this one. Walking west increases the first one and decreases the last one. Increases the first one and decreases the last one. Oh, this is wrong. We should do this the other way around. Like, yeah, I'm missing east-west. Like if we look at this, east is going right. Yeah, I flipped the signs here. This should be a +1, this should be a -1, and this should be a +1, and this should be a -1. I mixed up east and west. So west is going left, which decreases the first one and increases the last one. Yeah, so does this now do what we want? 10, yes. This seems to be doing what we want. So let's remove our debug logging and run it on the input. 322. 322. That's the right answer. Yeah, so this now works. Great. First star, done. The tile floor in the lobby is meant to be a living art exhibit. Every day the tiles are all flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. This is cellular automaton thing. We did that already in a previous problem. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. This has the same nice property we had before, which is that like all the whenever a tile is affected, one of the tiles in its neighborhood will be black. And because we only store black tiles, like we don't store all the white tiles, we can iterate over all our tiles, and we will definitely hit all tiles that are flipped, or at least all neighborhoods of tiles that are flipped. So here tiles immediately adjacent means the 6 tiles directly touching the tile in question. This makes sense. Rules are applied simultaneously to every tile. Put another way, it is first determined which tiles need to be flipped, then they are all flipped at the same time. So we need to create a new grid and store the new version in the new grid. And the above examples that is passed in as following. After executing the process for a total of 100 times, there would be 2208 black tiles facing up. Oh, yeah, so this seems pretty simple based on what we already did. So let's do the func grid, the daily flips, and this will return a new grid. This will not happen in place. Yeah, because it happens to all of them at the same time, so we need to keep a separate version around anyway. And so let's say out will be a new grid. And then we will go through all tiles, all hexes in the grid in range G. And for each, so I will now just for each tile in the neighborhood, like I will now for each tile that is in our grid that we have where we have defined the grid, also look at the neighborhood. I might even skip. No, it's fine. Cool. So to iterate over the neighborhood of the, like, because for example, like it's not like if we have a black tile, we don't necessarily have all the neighbors stored because there might be just the default white state. So we do need to explicitly iterate over all neighbors of the cells that we have defined, but we know that we will always hit all of them. So we will first iterate over all the neighbors, and the easiest way to do that is to say for I is direction 0, I is less than, let's look at direction, or like n directions. This is how many directions there are, which is 6. I++, and so this is a pattern where we're just saying like, oh, let's just iterate through them numerically. Like we don't even care in what order we iterate through them. We will just iterate through all of them numerically. And then we say that the neighbor will be x.walk in the direction, let's just call this D for consistency's sake. We will walk into D. So n will be the neighbor of the cell we have looked at. And now for this neighbor, we need to check if it has 0 or more than 2 or whatever neighbors. Right? So the first, let's go through the neighborhood thing is just so that we hit every tile that can possibly be flipped. And the second loop, which will do the same, d less than n direction. Yeah, so n direction will be will be 6 because like east is 1, southeast is 2, east is 0, southeast is 1, 2, 3, 4, 5. So this will be 6, and so this is a like convenient little trick that you can use if you use like Jota to define all possible values. You can like just add in a constant at the end, and then get the number of entries you have. Anyway, so now if for the so now we want to count. So we want to count the number of black tiles that are adjacent to it, and B number of black tiles, and we say if the color of G at n.walk into the direction of D. So if from the neighbor that we are looking at right now, walk in direction D, what is the color of that? And if it's black, we will increase the number of neighbors, the number of black neighbors. And now we can say if G of the cell, like now we can say if it's a black tile, we need 0 or more than 2. If it's a white tile, we need exactly 2. So if Gn is black and the number of black neighbors is 0, or the number of black neighbors is larger than 2. If it's black and it has 0 or more than 2 black neighbors, then flip it to white. I don't know if I should even remark on it, but like I hope what I say is not taken out of context. So if the cell we are looking at is a black cell and it has 0 or more than 2 neighbors, we will say out of this cell will be black. Else if G of n is white and the number of neighbors is exactly 2, then it's also black. And we don't need to store white tiles in the grid because every tile is white by default. Right, so this should just do the daily flip. Then we say return out, right? So we go through all the cells that we know about. We go through all the neighbors of this cell so that we hit every possibly flipped tile. We count the numbers of black neighbors by going through its neighborhoods, and we check this out, and this should be fine. Yeah. So we might set a tile, like we will hit all tiles basically multiple times, because like we look at the tile and then we walk one step into a direction and then we walk like at some point a step back to look at it again. So we will like probably hit things multiple times. Like we will definitely hit things multiple times, but that's fine. Like we can set the value to the same value multiple times, the key to the same value multiple times. That's fine. And so now we can just say, let's just, for clarity's sake, print all of these values, or like at least the first 10 or whatever, to see that we've done everything right. So for I0, or like I1, I0, I less than 10, I plus plus. Let's do this. G equals G dot daily flip dot print at day %d, and the day will be I, and the number of black tiles will be count black tiles, and let's see, daily flip, it's daily flips, I assume. Yep. And run it on the input. Number of black tiles, 320. Oh, let's run it on a test case. We wanted to do that first to see whether we did everything right. We didn't. So, because we start with, in the above example, the number of black tiles that are facing up after the given number of days has passed. So, applied simultaneously to every tile. Put another way, it is first determined, that's fine. Directly touching this is also fine. It's meant to be a living art exhibit. Any black tile? Oh, any black tile is flipped to white. Oh, this is what I did wrong. Daily flips. So, this one. If it's black and this is the case, it should be flipped back to white and not left black. And so we need to, actually, if we want to know if a black tile remains black, we need to invert this condition, which is convenient because we can use De Morgan's law. So to flip this conditional around, we can first add a not in front of both of them and change this into a and then we will do this and do this. So yeah, and now we got rid of a couple of parentheses for precedence. So if it's a black tile, yes, I think you're right. Let me hi, Paul, by the way. You are allowed to say hi when you join. If it's not 0, and if it's less or equal than 2, then it will remain black. If it's 0 or more than 2, yeah. So yes, you are of course you're completely right. This is equal 1. I was, for the record, I was walking through it very slowly. Oh, now you are. Now you are correcting yourself. Yes, you are correctly correcting yourself. You are... I will leave it at this. because you are of course correct that it's equivalent to it being 0 or 1, to it being 1 or 2, but if I use the or sign, it will, like, I need parentheses to make, like, for the conditional. Otherwise, I can just do it like this. So I will just leave it like this. I think this is fine. And does it now? Now it outputs other things that look more correct. 15, 12, 25, 14, 23, 28, 41, 37, 49, 37. Yeah, this looks fine. So let's just do the 100 things to make sure that we print the right thing. Yeah. So at day fim.println number of black tiles on day 100 will be this. And then we run it on the input, and then hopefully we are done. 3831. You saw that it took like a noticeable amount of time to do all the flips. So there's obviously we can obviously improve or optimize this. 3831 if we would want to. I don't, but and that's the second star. So this was like, when I looked at the problem, I was very happy to see that it's one of the easier ones. That it would probably be like not a huge problem to do after yesterday's debacle. Of course, I was also like, it might be a bit cheaty, but also like I was lucky to just have come across this post, because otherwise I would have, like, I think this problem for the most part was figure out how to represent a hexagonal grid, and I was just lucky to already know that, or like at least know where I can look it up, because I remembered that I saw this. It's a really good blog post. I would encourage you to like check it out if you ever come across anything like this. As I said, like I linked it in the description. It's obviously super helpful, but apart from that, it's basically like it's the same problem we already had. Like we already had a cellular automaton on a rectangular grid at some point. So this is just like slightly more awkward by using different coordinates. And I guess, so one thing that I was surprised by, as the naive German I am, is that there are actually like at least 25 days in the Advent calendar. I actually thought it would just be 24, because in Germany we tend to like celebrate Christmas on Christmas Eve, and not on Christmas Day so much. So I will probably be back tomorrow, but I also think I do have. So I still have two things open. I have day 23 open, which is yesterday, which I will not do on stream because, like, I do want to do it, but I do not want to do it on stream. Day 20, I don't know. We can just have another look at day 20. I know Paul, who's here, has already seen me tackle it at least once or twice and revisit it once. And so far, what, like, in the second part, in terms of, like, we are supposed to count these sea monster occurrences, and I was confused because I thought I found them all, but I didn't. And a friend of mine, or an acquaintance of mine, ran his code on my input and provided me with told me in no uncertain terms that I screwed up and that I didn't find all of the monsters. Even though I do in a test case, I apparently don't do in the actual map. So I now have more information to try to debug what I did wrong here. And let me find his tweet to be, which I am gonna do in this thing, and then we can just have a look at my map and see why I don't find them all, because like my code obviously is correct, so there must be something wrong with the map. or with their verification code, because it can't be wrong. Okay, so this is the tweet. Zip, zip, zip. So yeah, Matthew kindly provided me with a list of like, I don't know, 8 monsters or whatever that he found. 2, 4, 6, 7 monsters that he found, and we can try to figure out what is going wrong. So let's look at day 20 once again. Day 20. So I guess today's problem was how the flip multiple direction simultaneous counting is supposed to be done. You are talking about day 20, right? Like, I talked to him a bit. What he said is he searched in all directions, but only one had matches. I'm not quite sure whether he meant he looked into all directions, like he flipped the map in all directions, or whether he looked at the monster in all directions. They probably should be the same, like equivalent, but as long as there are, and so I also asked him about the non-overlapping thing, and he sanity checked that for me, and then he like ran it and told me. So my hope is that if we look at the coordinates he sent me, we can see whether the monsters he found are in the orientation that we look for them, and if they aren't, we hopefully can see like what direction we have to look at, and if they are, we hopefully see that like there's some other directional thing going on. So I hope like just having a list of things that we haven't found yet. I think I assume I found at least one of them. So I hope we use the same map direction, but we will just see that in a second, I think. So this is my map, which I have helpfully stored. One second. These are the monsters we found. So if we go to like line 27, I think we start at we start at 0 to count. Yeah, I'm super thankful for Matthew. I met him a couple years ago in London when I was still living there, and it's very useful to know him. So, and the shape of the monster we have in the file. So let's see whether we can see the monster manually by looking at it. DDOP, rotate tile. This is the sea monster shape that we use. And so, surprisingly, I don't see. There's supposed to be one at 2744. Am I printing XY or am I printing YX? Confirmed. At P, and P is row and then column. I think, yeah. Row 22, column 44. So this should start like here, shouldn't it? Maybe I'm referring to this. Wait. This Vim starts obviously at. Vim starts counting at 1 obviously, and I start counting at 0. So it's line 28 in the actual file. And so this is the shape that we are looking for. And so this 27 monster is this one. 1, 2, 3, 4. I don't know if this is even visible, but it's fine. Oops. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. And so this is the monster, that we found. Oops. Now, let's see if he has also found that. Yx, counting from the top left. So he uses the same coordinates I use. He has not mentioned this one. Has he mentioned any of the ones I have? 2744? Nope. 3555? Nope. Okay, so he has not listed any of the ones I found. 2644. This is the one. So he obviously uses the first row where my coordinates always refer to the second row, where the second row of the monster starts, because we started matching for this because it has more hashes in it. Whereas his starts at this row. So the 44 is the same, but the other coordinate is offset by 1. 27, 44, 26, 44. So let's look at 2170. 21, which is 22. And then row 70. Yeah, so he says he found a monster here. Can we see one? So this should be the topmost row. Wait, so he says it's at, no, 2117. I'm an idiot. 17. So he says there's a monster here, I guess. Oops. What are you doing, Vim? Again, 17. So, can we see a monster? Yeah, I guess this... No, this isn't a monster. Swimming to the right. So, 22, 17. So like this would be the hat, like this would be the 3 of the hat, but this doesn't fit. None of these fit. You just corrected 70 to 70, 17. Yeah. Yeah, the stream is like 20 seconds behind. Undo. So again, 22, 17. So he says there should be a monster here. But oh, this could be it. So this could be the hat. And then this is it, right? Yeah, I think this is... There is one here. And we apparently are not finding it. Zip. So it is in the map, but it seems we are overlooking it for some reason. Weird. So, let's see. If tile is... So this, let's say, if I is 22, no wait, yeah, yes, 22, matching this line, log.print match %q. Let's actually do it differently. Let's do this. Let's use the Go playground and just let's do copy this out. Nope. Copy this, and then let's take the lines. These are the 3 relevant lines, I guess. Nope, not what I want. So that's the input, and now let's see if we can find a monster. And if not, wonder what's going wrong. In println found monster. Undefined. Yeah, that makes sense. In 1 1 minus 1 1 plus 1. Yeah, 0 1 2. Yeah. Found monster. So this says it finds the monster. Do we find it? No, we don't, right? It's not in this list. Count sea monsters. Oh, so this code actually looks, this just looks whether it finds it. Okay, so this code seems to see the monster at least. So it's probably this code that is wrong. Which wouldn't be a huge thing to func count monsters. So, and instead of doing len tile, this will be in all of this is right, all of this is right, in confirm sea monster add. So let's do count monsters in. Doesn't say anything, so it doesn't seem to find it. So let's see why. Log.println middle line does not. So wait, let's actually do a fm.print matching %q, because this is the stuff that we match. Fm.print not found. Otherwise, okay, let's see what this does. Matching this. So this is the second line. This is actually the line that we are looking for. And it does seem to find something. Okay, so found one, adding %d, I log 0 plus j. Found one. Adding 117. Yeah, 1 and row 17. So this looks fine. And this P0 minus 1, P1 to P1 plus 20. So now, this look, it does add the candidate, but then apparently it doesn't continue. Oh my god! Yep. Yeah, I only matched. Copy paste error. I matched the first line twice. So now I found a lot more monsters. Let's see if everything he found is also in our list. So 329 is 429 in our case because we look at the middle row. 470 is 570. 1240 is 1340. 1518. 2150. Yes, great. This looks exactly like what we want. So number of non-C monster hashes should be this. That's the right answer. We got our second star. Great. Yeah, it's a dumb bug, and that's what happens if you write dumb bugs. And for some reason, it seems that even though like I did that in the test input, I guess both lines matched. Like because yeah, I don't know. Which actually makes sense because if you look at the so if we look at the C monsters, right? Like what happened is we matched this thing twice, and this thing is basically like all dots except like at one specific point there needs to be a hash. So the probability that if we just take any random part of the map and match it against this regular expression, the probability that it matches is actually pretty high. So this is why we still like counted the correct number of monsters in the test case, because just by coincidence the line also had a hash there, so that's fine. Whereas in like some of the in some of the stuff, like the line below didn't have the hash at this point. Yeah, anyway, so happy, joy to the world, Christmas present, whatever. We got the second star for day 20 finally. And I think we'll leave it at that. Like it's a good hour, which I think is fine. I am just, I don't know. Yeah. So I think that's good. We will leave it at that, and I will thank Matthew and tell him that he's been a guest star on my stream. Thank you all for watching, and I guess I will try again tomorrow.